This presentation will cover the Requs Software FMEA basic capabilities. The Requs Software FMEA is developed by Mission Ready Software. Its purpose is to expedite the time to complete the software FMEA while also dramatically improving effectiveness. The way it improves effectiveness is it automatically calculates the likelihood of the most common software failure modes. That is a dramatic time reduction, and people spend a lot of time arguing over likelihood. It does it for you. It is built on the world's largest database of software failures analyzed by root cause. That's another reason why it's effective. Instead of looking at failure modes that don't really happen all that often, this is looking at the ones that happen quite a bit. Our company has been analyzing software failure modes and root causes since 1993. Our data represents defense, medical, electronics, equipment space, aerospace, and many other industries as well. So this tool, it does not matter what industry you're in. We've got failure modes that honestly come from virtually all of them. This is how it works, and there is an additional video available on YouTube. The user enters information about how the software will be developed and about the software itself. So what are its basic capabilities? How will it be designed and tested? If you know any of the design controls, you can enter that. You describe the known hazards for the system and the severity of those known hazards. If you know it, you can describe the states of the software or system, as well as the hardware and software components and the communication interfaces. Once you enter in as much as you know, the software goes to work. It determines which failure modes and root causes apply, the likelihood of those that do. It recommends some potential design controls and potential mitigations for those root causes. At that point, the multifunctional team is free to do the thing that they are the best at. That's looking at those local effects and expanding them upwards to the system effects and hazards. That's what they're very good at doing. The tool allows them to spend more time on that and less time on the tedious aspects. At that point, the software tracks the risk and the action items to closure. So the first step is to answer as many questions as you do know the answers to. The very first thing you're going to want to describe is what is in your software system. What does it have? What does it not have? These are simple questions to answer. It is from here that the software will determine the root causes that apply. So for example, if your software doesn't have a database, then the root causes related to a database will not apply. It's that simple. You will also answer things that you might know about any current customer complaints. If we know what the customer complaints are, we can determine what the underlying failure mode is. And you can enter in any known failures from the past if it's an existing system. You can enter in any design controls here. You should also just describe and go to the testing tab and describe any known tasks that are going to be planned for this software system. These inputs are not terribly difficult to answer. Okay, from there we go to the FMEA tab and select the known hazards tab, and here's where you can import or you can enter the list of known hazards. The hazards could be safety, they can be mission, they can be both. They could be monetary related hazards. You get to define the severity and likelihood range there to be any scale you want it to be, from 1 to 10, any number of risk levels there. And once you enter in your hazards and tag them to the appropriate severity, the software will then allow you to simply tag each root cause to one or more of these hazards. Okay, the state tab is next. If you happen to know the states of the system, you can either import them from an MBSE tool or import them from Excel, or you can type them in. The states of the software system are normally pretty easy to find. They're normally in a system requirement, a user requirement, a software architecture diagram. Normally this is one of the first things that is thought out with regards to the software. And so getting this information shouldn't be terribly difficult. And once you import or enter that information, the software goes to work. It generates failure mode rows for the known state-related root causes. Some examples are prohibited transitions are allowed by the software when the conditions aren't met. So in this example, the system might go from heat to air conditioning without a user command. The software could also get stuck in a state. That means it fails to transition when it should. So the user, for example, commanded a transition from heat to air conditioner, but the software didn't execute it. That would be an example of a stuck state. The software might also encounter an abort or a loss of power while in any state. So let's say the system is on heat and there's a loss of power. When the power resumes, what state will the software be in? Will it still be in heat? Will it be in some other state? If it comes back up and it's in air conditioning, that could be a hazard. So the software does the work here with the state-related root causes. Next, you'll enter in all the other components in the system at a fairly high level. You don't want to enter in every nut and bolt. That's not what we put in here. We put the major components. You can see with our thermostat example with the heating element, cooling element, temperature sensor, the thermostat itself, the ventilation unit. We're not listing every nut and bolt. We also have the basic communications. So once you enter in the basic components, the software generates FMEA rows for the known root causes for the software failing to detect and properly handle hardware faults and communication faults. The software is the intelligent component in the system. It is either implicitly or explicitly its job to know when the system is faulted. Okay, once we've entered in as much information as we know, and this is often an evolving process. As things move along, you may know more information and you can update what you know. At this point, we get to the Effects tab, and you can see there is a listing of common defect enumerations, CDE, and failure modes. The first thing, there's 174 of these at the moment. There could be more as time goes on and the CDE is updated. You can see the first thing the software does is determine, is this CDE applicable or not? In the case of our thermostat, the thermostat only has one user at a time. At least one thermostat only has one user. So these two root causes here are not applicable because there aren't concurrent users. Now, you do have the capability to override. If our software determines something's not applicable and you disagree, of course, you can override that information. We give you the ability to do that. The software also provides an initial entry for the root cause and local effects, which you can update. If you're familiar with other root causes or local effects, you can update them. At that point, you're going to connect this information, particularly these first 4 columns, to the next level effect. The software provides for up to 5 levels of effect. You can tailor them as you see fit. They can be effects on the system, effect on safety, effect on the customer, effect on the user, effect on the company profitability. There are software failure modes that just one of them can cause the company have severe financial distress. So we allow you to tailor the effects. You can enter in as many as you want. Now, once you've entered in the effects, this is the time to tag that effect to one of the hazards. Okay, so this is where the hazards you entered, they're going to pop up on a pull-down menu. You could select the one that is the most appropriate or the most severe and tag it to that root cause. This reduces quite a bit of time later in the traceability and the results. Next, you will select the likelihood tab, and once you do, the software will compute the relative likelihood of each of the common defect enumerations. It will also present to you some preventive measures. Preventive measures or preventive controls are things that can reduce the likelihood of the root cause, but they don't fix the root cause. That's not what they do. They just make that root cause a little less likelihood. So how does likelihood computed for software? We have a whole training class on this. The short story is, it's based on 4 things. Does the root cause even exist? 2, if it does, is it a single or multiple point failure that will result? 3, how many independent design controls we have. The more we have, the less likely it is to cause a failure. Doesn't mean it doesn't exist, it just reduces the likelihood of the defect causing the failure. And finally, detectability. Detectability for software is from the development point of view, not the users, because the users can't fix the problem. They can't see the failures before they happen. So the detectability here is directly related. Is the software group going to test for this root cause or not? If they're going to, and they even have a written test procedure to test this particular root cause, the likelihood of it is reduced largely because once they run that test, they have an opportunity to fix it. Okay, next is the mitigations. The user might be able to reboot or work around, but they can't change the code. They can't eliminate the root cause. And with software, as long as that root cause is in the software, it can continue to wreak havoc. It can cause a failure every hour, every day, every couple of weeks. And so the user can work around it in some cases, but they can't remove the fault. And so that's what design changes do. Specifications, design, code, test procedures, and user manuals are the things that are typically updated to as part of the corrective action for each root cause. We do have some potential corrective actions here, which you can choose to ignore or review, either one. At this point, you type in the corrective actions. Not all of these are applicable for every fix. You don't have to change the specification for every fix. You don't have to change the design for every fix. So you enter in the appropriate column what needs to be fixed. All right, once you have the FMEA inputs, you're probably going to regularly output the FMEA. So even before it's complete, you're going to want to export it. This is the part, the critical items list tab, where you get to export it. You can export the whole thing. You can export only those root causes that are relevant. You can export only those root causes with a certain severity level. And you can export only the root causes that tag to a certain hazard. The output does support multiple industry standards. You can tailor the format of the FMEA sheet to meet various standards. One thing I do want to point out is hardware-centric columns are in these standards. Our software does not export those because they do not apply to software. Now, if you want to tailor the worksheet to have those in it for some reason, that's up to you. But we don't support columns that are only for hardware. Okay, some conclusions here. The Requs Software FMEA is the only tool that intelligently calculates the likelihood and the relevance of the most common software failure modes. It is part of a family of tools, and that family of tools is the only product that does both quantitative reliability predictions and software FMEAs in one product. And it does so before the code is written, which is very important there. The Requs Predict FMEA tool is the only software tool that will automatically generate large portions of the software FMEA just based on a question and answer session. It is built from the world's largest database of software failures that have been analyzed by root cause. Now, if you're interested, you can get a free 7-day evaluation. We have the link there. Once you download the software and install it, you can contact support at missionreadysoftware.com to receive your activation key.